Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about the laws of radicals. So without further ado, let's do this topic. So we do have 4 laws of radicals and we will be explaining this one step by step for you to really understand how to simplify equations. Alright, so let's start in the first law. In the first law of radicals, it says that the nth root, quantity, the nth root of A raised to the power of n, and your answer is equivalent to A. So that's the first law there, and we will be explaining that one. And we will give more examples for you to really understand how to simplify these equations. Now for rule number 2, we have the nth root of A multiplied by the nth root of B is equivalent to the nth root of A times B. And for number 3, the nth root of A over the nth root of B is equivalent to the nth root of A over B. And for number 4, we have the m root, and the nth root of A is equivalent to m n root of A. So just simply multiply the roots and your answer will be this one. So, and you can also interchange this m and n. You have n m root of A. Alright, so let's focus first on number 1. So the nth root of A, quantity, the nth root of A raised to the power of n, the answer is A. Now, this one, remember class, that the quantity of nth root of A raised to the power of n, you can also write this one as the nth root of A raised to the power of n. So once again, this is just the same class. This exponent n, you can put it inside this radical symbol. So put this n, it will be the exponent of A. So this is actually the same, the nth root of A, raised to the power of n. So just put this n in the exponent of A. This is just the same. Now, when you convert this one into exponential form, you can write this one as A. Then this n will be the numerator. This, remember class, rational exponents. Converting rational exponents into radicals and vice versa. So I have a link for that in the description down below on how to convert radicals to rational exponents and rational exponents into radicals. So this n, this exponent here will be the numerator of the fractional exponent, and this n, the index, will be the denominator. And A raised to the power of n over n, you can divide this one, and divided by n is 1, so you can cancel this out. So this will be A raised to the power of 1, right? And A raised to the power of 1 is equivalent to A. So that's why, if you have this kind of example, if the index and the exponent, they are the same. So if they are the same, you can just simply cancel this out, and your answer is A. What is the number inside the radical is the answer. I hope you get this one class. If the index and the exponent are the same, you can just simply cancel the index and the exponent, and you copy the number or the equation inside the radical symbol. And the answer is A. Now, there is an exception for this one class. You need to remember this one. If A is less than 0, and then your n is even, your answer class will be the absolute value of A. Remember this one. Your answer will be the absolute value of A. Once again, A is less than 0. What do you mean by less than 0, class? A is less than 0. So, in example, class, if the number inside this radical symbol is less than 0, so these are numbers less than 0. We have negative 1, negative 2, negative 3, and so on, right? These numbers are less than 0. Negative numbers, that would be less than 0. So, if your A, the number inside this radical symbol is negative, and then your n is even, your n, the exponent is even. So what do you mean by even? Even numbers, class, that would be 2, 4, 6, 8, and so on. So your answer will be the absolute value of A. Your answer will be the absolute value of A. What do you mean by absolute value, class? Absolute value, it means that your answer is always positive. So, the absolute value of a number, your answer is always positive. Just remember that one, class. The absolute value of A, that would be always, your answer will be always positive. Now, what if, sir, if A is less than 0 and then n is odd? So, if A is less than 0 and then n is odd, so what do you mean by odd numbers? Of course, less than 0, that would be -1, -2, -3, and so on. For odd numbers, we have 3, 5, 7, 9, and so on. So if a is less than 0, so what if a is less than 0? The number inside this radical symbol is negative, and then your n is odd. So the exponent, example, the exponent is 3, 5, 7, or 9, or 11 is odd. Therefore, just simply copy, class. Simply copy the equation or the number inside. Okay, the equation or the number inside. So I hope you get this one, class, but if not, do not be worried. We will be explaining this one step by step. We will be having examples for positive numbers and for negative numbers. So let's start. Alright, so let's try an example. So example number 1. So what if you have example number 1? So what if you have the square root of 2 squared? So what would be the answer, class? The square root of 2 squared. That's correct. Your answer is 2, right? Do they have the same index? No. Always remember this one. In every square root, if you didn't see any number for the index, understood that the index here, class, is 2. Once again, the square root of 2 squared, understood that there's 2 here. The index here is 2. So if the exponent and the index are the same, you can just simply cancel this out, and our answer will be 2. Simply copy the number inside this radical symbol. Alright, let's try number 2. What if you have the fifth root of quantity x, y raised to the power of 5? So what will be your answer, class? Could you try that? Alright, that's correct. So the exponent and the index are the same. So fifth root of quantity x, y raised to the power of 5. Same exponent and index, so you can cancel this out, and your answer will be xy. Easy, right? For rule number 1. Let's try number 3. So what if you have the fourth root of x raised to the power of 4? What would be the answer, class? Fourth root of x raised to the power of 4. That's correct. The answer is x. You can cancel this out. Same index and exponent, so the answer is x. So our examples, class, are still positive. We will be dealing later on with negative. So what if you have this one? Example number 4. Okay, let's try this one. Example number 4. The cube root of 8x cubed. So the cube root of 8x cubed. How will you simplify that one? So for the cube root of a number 8, do you have a cube root of 8, class? What do you mean by the cube root of 8? Now, the cube root of 8, the cube root of a number, it means that you think of a number that when you multiply it by itself 3 times, the answer is 8. Do we have a number, class? The cube root of 8? Do we have a number that when you multiply it 3 times by itself, the answer is 8? So, let's try 1 times 1 times 1. That is 1. Let's try 2. 2 times 2 times 2. That is 8, right? So, therefore, the cube root of 8, that is 2. Or you can also write this one as the cube root of, so the cube root of 8, that is 2 raised to the power of 3. Okay, or 8, you can also write this 2 raised to the power of 3, right? Is 2 raised to the power of 3 equivalent to 8? Yep. 2 raised to the power of 3, that's the same with 8. Because 2 times 2, that is 4, times 2, that is 8. So therefore, you can write this one as 2 raised to the power of 3 and copy x cubed. So same exponent and index, so you can cancel this out, and then cancel this out. So therefore, the answer is, the remaining will be 2x. Or you can also write this one, class, as the cube root of 2x quantity raised to the power of 3. So in the laws of exponent, class, you can distribute this one. So 2 raised to the power of 3, so 2x quantity raised to the power of 3. You can distribute that one, that would be 2 raised to the power of 3. And then distribute it from x, that would be x raised to the power of 3. And then, your answer will be the same. So you can cancel this out. And your answer will be the same, 2x. Easy, right? So you try this one, class, for rule number 1. And you put your answer in the comment section down below. Let me check if you really understand this rule number 1. What if you have the cube root of 27? Okay, 27 y cube. What if you have that equation, class? You try that one. The cube root of 27y cube. Could you try that? And you put your answer in the comment section down below. Alright, so let's try a negative example. So that's it, class. If the equations inside the radical symbol is positive, very easy, right? Just simply copy. Okay, simply copy and then copy the equation inside the radical symbol. Cancel the index and the exponent. So for 27, class, you think of a number that when you multiply it by itself 3 times, you get 27. And for this y cube, you can just simply cancel 3. So you try this one, class, and you put your answer in the comment section down below. For number 5. Now, sir, could you try a negative example? Let's try that, class. Alright, let's try an example, class. What if a is less than 0 and then n is even or odd? Let's try example for that one, class. Number 1. What if you have the square root of quantity negative 5 raised to the power of 2? Alright, of course, we know that the index and the exponents are the same, right? Because we know that in every square root, the index is 2. So we can cancel this out and then copy negative 5. But that's not your final answer, class. Always remember this one, that if a is negative, we have rules to follow. If a is negative, and then the index or the exponent is even number, so the value of n is 2, and 2 is an even number. Therefore, our answer will be the absolute value of this particular number. The absolute value of a. Okay, our a here is negative 5. The absolute value of negative 5. And the absolute value of a number is always positive. Once again, class, always remember the absolute value of a number is always positive. Therefore, our answer is positive 5. This will be our final answer, class. Positive 5. Okay, always remember, class, the absolute value of a number is always positive. The absolute value of 3, that's positive 3. The absolute value of negative 6, that's positive 6. So that's it for the absolute value. So once again, if the number inside is less than 0, negative 5 is less than 0, and then n is even, therefore we need to get the absolute value of this particular number. Okay, and make sure, the class, that the index and the exponents are the same. Let's try another example, class. What if you have the cube root of quantity negative 2 raised to the power of 3? Alright, so the index and the exponents are the same, so we can cancel this out. And our answer is negative 2. Now check it. Is this our final answer? This will be our final answer? Is this our final answer? So let's check. Is a less than 0? Yup, negative 2 is less than 0. Next thing to check, is n an even number or odd number? 3 is an odd number, so therefore we just simply copy a. So our answer is negative 2. That's it, class. That's the rule there, class. So now you will be asking questions, sir, why is it that this answer number 1 is positive 5? So let me explain that one, class, step by step. Because it will take time, class, if you do it this way. Okay, the square root of negative 5, quantity negative 5 raised to the power of 2. If we simplify this one, class, negative 5 raised to the power of 2, this is the same with negative 5 times negative 5, right? And negative 5 times negative 5, that's positive 25. I hope you're still with me, class. This one, negative 5 squared, it means negative 5 times negative 5. And negative 5 times negative 5, that's positive 25. And the square root, okay, the square root of positive 25, that's positive 5. That's why you have positive 5 as your answer, class. If you do the long method, but once again, it will take time. Same with this one, class. The cube root of quantity negative 2 raised to the power of 3. If we simplify this one, negative 2 raised to the power of 3, this is the same with, you multiply this negative 2 by itself 3 times. This is negative 2 times negative 2 times negative 2. And negative 2 times negative 2, that's positive 4, times negative 2, that's equals to negative 8. So negative times negative is positive. Positive 4 times negative 2, that's negative 8. So this is negative 8, right? So when you simplify this one, this is the cube root of negative 8. Now, The cube root of negative 8, you think of a number that when you multiply it 3 times, by itself, the answer is negative 8. Therefore, that's negative 2. Because negative 2 times negative 2, that's positive 4 times negative 2, that's negative 8. That's why, class, our answer is negative 2. But once again, class, it will take time. It will be confusing if you do it this way. Just remember this one. If the number inside is negative, okay, and the index and the exponents are the same, then the index or n is an even number. Just simply get the absolute value of this a. Okay, just remember that one, class. So if a is less than 0 and then n is odd, simply copy, class, inside this radical symbol. Simply copy a. So let's try another example, class, for you to really understand this one. Example number 3. So what if you have the fourth root of negative 6 raised to the power of 4? Alright, the fourth root of negative 6 raised to the power of 4. Same index and exponent. Yep, we can cancel this out. Now, check, is a less than 0? Yep, negative 6 is less than 0. Next thing to check, class, is n even number? Yep, 4 is an even number. Therefore, we need to get the absolute value of this negative 6. So, absolute value of negative 6, that's positive 6. That's it, class. Easier, right? Let's try number 4. Okay, example number 4. The seventh root of negative 4 raised to the power of 7. Alright, so negative 4 raised to the power of 7. Same index and exponent, we can cancel this out. And our answer is negative 4. But check this one, class. Do we need to get the absolute value or not? Not. Why is that, sir? Because a is less than 0. Negative 4 is less than 0 because this is negative number. And then 7 is odd. Is 7 an odd number or an even number? Yup, that's correct. 7 is an odd number. Therefore, we just simply copy a. So, this will be our answer, class. Negative 4. Alright, so you try this one, class, and you put your answer in the comment section down below. Let me check if you really understand this one, class. So, what if you have the sixth root of negative 2 raised to the power of 6? What would be your answer, class? Alright, so I hope you understand this one, class. If you have some questions, please do leave a comment in the comment section down below. And you can also message me in our Facebook channel, same name with our YouTube channel. Alright, let's try rule number 2. So, for rule number 3 and 4, we will just make another video for rule number 3 and 4 because our video will be quite long. Alright, rule number 2. So, in rule number 2, it says the nth root of a multiplied by the nth root of b is equivalent to the nth root of a times b. So, let's try an example, class. Example for this one. So, once again, if they have the same index, simply copy the index and multiply this number, okay, inside a and b, or multiply the equation inside this radical symbol. So, example, class. Example number 1, the square root of 20. Now, to simplify this one, class, the square root of 20, you think of two numbers that one number is a perfect square, the other is not. So, do you still remember, class, the perfect squares? We have 4, 9, 16, 25, 36, 49, and so on, right? These are perfect squares because when we get the square root of this particular number, our answer is a whole number, right? What would be the square root of 4, class? That's correct. The square root of 4, that is 2. Square root of 9, that is 3. The square root of 16, that is 4. Square root of 25, that is 5. Square root of 36 is 6. Square root of 49 is 7, and so on. So, these are perfect squares. When we get the square root of this particular number, our answer is a whole number. Okay, once again, the square root of 4, that is 2, because 2 times 2, that is 4. So, you think of two numbers, class, that one number is a perfect square, the other is not, in which when you multiply the two numbers, you will get 20. Okay, because 20, class, is not a perfect square. You cannot see 20 here in the perfect square. So, the thing that you will do, you find two numbers that one number is a perfect square, the other is not, that when you multiply the two numbers, you will get 20. Of course, that would be 4 and 5, right? So, the square root of 4 times the square root of 5, that would be the square root of 20. So once again, if they have the same index, check class, the same index. Of course, the index here, class, is 2, right? Understood that there's 2 here. So for every square root, the index is 2. Understood, class, that in every square root, the index is 2. So the square root of 20, we can write this one as the square root of 4 times the square root of 5. If they have the same index, simply copy the index. Then you multiply the number inside. So 8 times b, that would be 20. 4 times 5, that is 20. So once again, for the square root of 20, we can write this one as the square root of 4 and the square root of 5. One number is a perfect square. 4 is a perfect square because the square root of 4, that is 2. And the other is not. So that's how you simplify class. So the square root of 4, that is 2. And the square root of 5, there is none. We cannot simplify square root of 5. So our final answer, that would be 2 square root of 5. That's it, class. That's the rule there for rule number 2. So let's try another example, class. Another example. What if you have the square root of 18? So how will you simplify this one, the square root of 18? So the square root of 18 is not a perfect square. So therefore, you find two numbers, that one number is a perfect square, the other is not. So what would be the number, class? Divisible by 18. Find two numbers, class. That's correct. That would be 9, right? Can we divide 18 by 9? Yep. 18 divided by 9, that is 2. Or 9 times 2, that is 18. So one number is a perfect square, the other is not. So the square root of 18, we can simplify this one as the square root of 9 times the square root of 2. And what would be the square root of 9, class? The square root of 9, that is 3, because 3 times 3, that is 9. So the square root of 9, that is 3, times the square root of 2. Do we have a square root of 2? Nope, we don't have square root of 2, and we cannot simplify square root of 2. So therefore, 3, square root of 9 is 3. 3 times square root of 2, that would be 3 square root of 2. So this will be our answer, class, for number 2. Alright, easy, right? Let's try this one, number 3 example. Alright, so next, number 3, the cube root of 16. So is 16, class, a perfect cube root? Do we have a number that when you multiply it by itself 3 times, the answer is 16? Nope, we don't have, right? Because 2 raised to the power of 3, when you multiply 2 by itself 3 times, once again, 2 raised to the power of 3, class, it means 2 times 2 times 2. When you multiply 2 by itself 3 times, the answer is 8, right? 2 times 2, that is 4, times 2, that is 8. And then for 3 raised to the power of 3, 3 raised to the power of 3, that is 27, right? Because 3 times 3 times 3, 3 times 3, that is 9, times 3, that is 27. And 4 raised to the power of 3, so 4 times 4 times 4, that is 64. Therefore, 16 is not a perfect cube. So the thing that you will do, class, in this example, you find two numbers that one number is a perfect cube, and when you multiply the two numbers, you will get 16. Do we have a number, class? Factors of 16, that one number is a perfect cube and the other is not? Yup, we have, because 16, we can simplify 16 by 2 times 8, right? One number is a perfect cube, the other is not. Is 8 a perfect cube? Yup, 8 is a perfect cube because 2 times 2 times 2, that is 8. So therefore, we can simplify this one as the cube root of 8 times the cube root of 2. Okay, for number 3, you find a number that one number is a perfect cube and the other is not. Okay, because 8 times 2, that is 16. The cube root of 8, what will be the cube root of 8, class? The cube root of 8, that is 2. Why is that, sir? Because 2 times 2 times 2, that is 8. And the cube root of 2, we don't have. So our final answer, that would be the 2 times the cube root of 2. So that would be 2 cube root of 2. Simply copy this one, class. 2 cube root of 2. That's our answer, class. Once again, if you're confused with this one, the cube root of 8, you can also write this 8, the cube root of 2 raised to the power of 3. This is just the same, class. 2 raised to the power of 3, that is equivalent to 8. Because 2 times 2 times 2, that is 8. And then you can cancel this out because they have the same index and exponent. Copy 2. And then simply copy this one. Cube root of 2. 2 cube root of 2. That's it, class. This is the answer for number 3. Alright, easy, right? So you try number 4. You try this one, class. So what if you have this one? Let's have an equation, class. Example number 4. The fourth root of x raised to the power of 7. So the thing that you will do, class, is you need to factor this out. We can factor this out, class, by the fourth root of x raised to the power of 4 times x raised to the power of 3, right? X raised to the power of 4 times x raised to the power of 3. Alright, so you can make this one individually, class. You can write this one as the fourth root of x raised to the power of 4 times the fourth root of x raised to the power of 3. This is just the same, class. Okay, the fourth root of x raised to the power of 4 times the fourth root of x raised to the power of 3. But I will just make it like this, class, to make it simple. Okay, to make it simple. So we can cancel this out. Now, do you still remember, class, in the laws of exponents, if they have the same base, x raised to the power of 4 times x raised to the power of 3, if they have the same base, simply copy the base, then you add exponent. 4 plus 3, that is 7. Alright, so we have the fourth root of x raised to the power of 4 times x raised to the power of 3. Now, since this is the same index and exponent, so you can cancel this out and you put it outside the radical symbol. So copy x, and then we cannot cancel this out because this is 3 and 4. 3 is not divisible by 4. So simply copy the fourth root of x cubed. So that would be our answer, class. So what if we have the fifth root of b raised to the power of 11? So the thing that we will do, class, is we need to factor this out. Why is that, sir? Because we cannot divide 11 by 5. Okay, so we find an exponent that we can divide that exponent by 5. So therefore, we can factor this out by the fifth root of b raised to the power of 10 times b, right? Because b raised to the power of 10 times b, understood that there's 1 here, same base, copy b, then you add exponent 10 plus 1, that is 11. So this is just the same, class. Alright, so we factor this out by b raised to the power of 10 and b. Because 10, we can divide 10 by 5. So this will be 10 divided by 5. So we have b squared. So 10 divided by 5. So 10 divided by 5, that would be b squared, the fifth root of b. So understood that there's 1 here. We cannot divide 1 by 5. So therefore, we already have b squared, fifth root of b. So this will be our answer, class. Because if we make this one, class, individually, just remember, class, making this one individually, we can write this one as b raised to the power of 10. So this exponent will be the numerator of the fractional exponent, and then this 5 will be the denominator. And this one, this b raised to the power of 1, we can write this one as p raised to the power of 1, okay, over 5. And to convert this one into radical, this one, we can divide this one, 10 divided by 5, that is 2. So that's why we have b squared. And then this one, we cannot divide 1 by 5. We get a decimal answer. Converting this one into radical, so that would be the fifth root of b raised to the power of 1. And you will get the same answer, class. Same answer. Alright, so quite tricky. Okay, quite tricky, right? Or another solution, class. Last solution. There are some students, class, that they will make it this way. Okay? You can write b raised to the power of 5 times b raised to the power of 5 times b. Why is that, sir? Okay, b raised to the power of 5 times b raised to the power of 5, that would be b raised to the power of 10, right? Same base, copy, then add the exponent. Okay, so 5 plus 5 plus 1, that would be 11, right? Same answer. Now, remember, class, if they have the same index, same exponent and index, you can cancel this out and you put it outside the radical symbol. So we have b, first b, then another b, times b. Then we cannot cancel this out because this is 1 and 5. So that's why we can copy fifth root of b raised to the power of 1. So fifth root of b raised to the power of 1. And b times b, that is b squared, fifth root of b. So you can have the solution, class. It's up to you. But it's better, class, that you have the solution. Alright, so that's the rule number 2. Quite tricky, right? For the last part. So you try this one, class, and you put your answer in the comment section down below. What if you have, okay, what if you have the fourth root of x raised to the power of 6 and y raised to the power of 9? What would be your answer, class? You try this one and you put your answer in the comment section down below. Let me check if you really understand our topic. So on the third laws of radicals and fourth law, I will just make another video for that one, class, because our video is quite long. And I hope you learned something new today. If you have some questions with rule number 1, rule number 2, feel free to leave a comment in the comment section down below, class. Once again, this is Teacher MJ. Feel free to see the next part of our video, class. Have a great day, class. Goodbye for now. Bye-bye.